So what we're covering right now is in section 4.5 of the book. It's titled Concentration of Solutions, so you guys will have to concentrate today. Yes, I recorded the joke. All right. Concentration, I think you guys probably understand this. Have you guys ever had to buy the concentrated orange juice at the store? So the chemistry definition of concentrated isn't any different than the regular definition of concentrated that we talk about in real everyday life. It's just like those concentrated orange juice cans. Okay. Concentration is a relationship. It's a mathematical relationship between the amount of solute and the amount of volume of solution, the liters of solution. Okay. As far as we're concerned, we're going to be using one version of this called molarity. Molarity is malaria. It's fun. Molarity is used to determine concentration of a solution. It's always calculated, it's abbreviated with a capital M, and it's always calculated the same way. Units for it are moles per liter, so check out what the calculation is going to look like. If you want to calculate molarity, molarity is going to be equal to the number of moles divided by the number of liters. And because of that, the units of molarity is moles per liter. Okay, so molarity is number of moles per liter, which is exactly what it says here, right? Molarity is moles of solute divided by volume of solution in liters. Do you need to write this one down if you have the shorter version written down? Some people might. Okay. The top is moles of solute, the bottom is volume of this entire solution. As far as this part of the chapter is concerned, there's going to be 4 definitions that might be new to you guys. I'll put those up in just a second here. All right. So the 4 definitions. One is going to be a stock definition. A stock is going to be a solution in its most concentrated form. Okay. You guys are going to be making up a stock solution today. Okay. For one of the lab has you make up your stock solution. Okay. Stock solutions are concentrated usually. Concentrated just talks about how much stuff is in it. Obviously, concentrated orange juice is more concentrated than regular orange juice. That's kind of in the definition, isn't it? We can use a word like dilute. Dilute means to add water usually, which means that you're going to make it less concentrated. Dilute can have another terminology also. It can be used as a noun. It can be used to describe a solution. So if you've got a stock solution that you added water to, you could call it your dilute solution. And lastly, there's one other key term here. The key term is hydration. Hydration is the term that's used when we talk about water molecules dissociating something that's soluble. Okay, so when it's actually taking it and tearing it apart, that's called hydration. Real problem, okay, because that's silly. Calculate the molarity of a solution made by dissolving 23.4 grams of sodium sulfates in enough water to form 125 milliliters of solution. So we've got to start with the 23.4 grams of sodium sulfates, which you've got to write the correct formula for, otherwise you're not going to get the molar mass right. Okay. The formula for sodium sulfate is Na2SO4. Is that what you wrote down? Yeah. All right. So we got to convert from grams to moles. 1 mole, I've got it written down here, 142.05. Do you guys concur? That means you guys agree. Yeah? Okay. All right. All right. So what that means is that we've put 0.165 moles into this solution. Okay? If I'm going to calculate the molarity of this, that's the number of moles per liter. So that means I'm going to put 0.165 moles over the liters, which, ooh, that's not in liters, is it? All right, so we have to put 0.125 down for liters. The answer winds up being 1.32, and I usually put an M on that, capital M, molar, 1.32 molar. All right. Here we go, guys. This is how we do this. All right. Molarity, the definition of molarity is moles per liter. They tell me the molarity right here. They tell me that this is the molarity of the stock solution we want to make. So I'm going to toss in 0.1086 in for M. The number of moles, we don't know. I usually abbreviate number of moles with an N. So if you look at my worksheet on the key, you'll see that I put N down a lot for number of moles. And then the number of liters, they say that they got 250 milliliters. 0.250 liters on the bottom, right? We do some algebra. We solve for N. Basically, we're multiplying both sides by 0.25. And N, the number of moles, is going to wind up being 0.0272 moles. That's 3 sig figs. I think I rounded that. So at this point, we've got moles, which isn't very useful because our balances don't measure in moles. Our balances measure in grams. So the next step is to find out how many grams I need. Okay, that uses the definition of molar mass. I know that it's 1 mole, and the molar mass was given to us up there as 249.69 grams per mole. Okay. So basically, I've got to multiply my 0.0272 by the molar mass. The calculator spits out a number that we round. 6.79 grams. So if I want to make up a solution that has a molarity of 0.1086 molar, and I'm only making up 250 milliliters of it, I need to put in 6.79 grams of copper sulfate pentahydrate. When you go back in lab, you're going to have something back there called a volumetric flask. Please don't drop or break the volumetric flasks. They are expensive. They're like 50 bucks. Okay. All right. The reason why they're so expensive is because there is a line etched on the neck of the bottle that is valued exactly at, I believe the bottles that we're using are 250 milliliters. They got 4 sig figs there. Okay, so they're valued exactly at 250.0 milliliters if you fill the meniscus to that line. Okay, so the methodology of making up your solution is going to be pretty simple. First step, you got to get your copper sulfate pentahydrate into your volumetric flask. So you're going to weigh out 6.79 grams of copper sulfate pentahydrate, and you're going to plop that in there. Okay, notice they used a funnel. And they used a little bit of water to help rinse all of the copper sulfate pentahydrate down. Okay. Once you've got the bulb about halfway full, what you want to do is you want to pick it up off the tabletop, not next to the tabletop, not next to the stick or anything, and you want to dissolve all the copper sulfate in that. You don't want to put it all the way up to the top. Dissolve it all the way up to the top. So it's not gonna slosh around very well if you fill it to the meniscus first. Okay. Once you fill it up to the meniscus, you guys are going to obtain a nice clean flask to put your stock solution in. Clean flasks are located in a box on the center lab table there. If it doesn't look clean, rinse it. Oh, and that's a good idea for today. If whatever you're using doesn't look clean, rinse it. Don't rinse it with sink water because sink water has stuff in it, right? Especially here in Lockport. use the DI water, the squeeze bottles. If we need to refill your squeeze bottle, that's no problem. I've got several jugs of water that we can pull out if we need to.